Welcome to part 2 of the notes for polynomials review number 3. We have a more complex example here that intertwines exponents, multiplication, and addition of polynomials. Okay. Now, the one thing to keep in mind is that the order of operations, that parentheses, exponents, multiplication or division, addition or subtraction from left to right, that those still stand. So when you see plus right here separating these two products, these two blocks of multiplication, you have to honor the fact that this needs to be simplified first, this needs to be simplified first before we can do any kind of adding to or subtracting from these two parts. So the first thing I'm going to do is actually rewrite this 2x minus 1 squared into 2x minus 1 times itself with the 3x plus 1 after that. Now from the previous example, you guys saw that, hey, if we're multiplying 3 blocks at a time, or three parts, you gotta just pick ones that seem like they would be good matches. The 3x plus 1 doesn't have anything special with the 2x minus 1. It's not a good twin, bad twin situation because 3 is not the same as 2. So it's not going to produce the squares, like we had x squared minus 4 in that previous example. This just isn't going to happen with rearranging. So I'm just going to do 2x minus 1 times 2x minus 1. And this is actually the part where maybe you guys don't necessarily need to rewrite the 2x. Maybe you just visualize it by saying, hey, I got a 2x in front of the 2x minus 1. What's 2x times 2x? Well, it's 4x squared. All right, so I did that one. And what's 2x times negative 1? Negative 2x. All right, now I cover up that 2x and ask myself, what's negative 1 times 2x? Also negative 2x. And then what's negative 1 times negative 1? Positive 1. So I save myself some time and space in writing out that actual stuff. If you feel way more comfortable by actually just writing it out as we did, and when I mean writing it out, I mean literally saying 2x parentheses 2x minus 1. Negative 1 parentheses 2x minus 1. I skipped that step. If you feel comfortable skipping the step, go ahead. Life is short. If we write too many steps down, we're going to miss out on other stuff. So then we can simplify the middle here. Remember, the 3x plus 1 is just chilling, waiting for its time to multiply by whatever this simplified version is. So 4x squared minus 4x, because a negative 2 minus 2 is negative 4 plus 1. Now this is its own polynomial. It's locked in, and then it's going to be multiplied by the 3x plus 1. So again, if you want to do the thing where you cover stuff up and multiply through, you can do that. In fact, why don't you pause the video now and see if you can multiply this out correctly all by yourself and check it with me. All right, here's what it looks like. You have, I'll map it out for you. I'll put the 4x squared first here, and then I'll put the 3x plus 1. I'll put the negative 4x here, then the 3x plus 1. Plus 1. So this ends up being 12x to the third power plus 4x squared, negative 12x squared. The details on these are very important. You could easily miss a squared or forget an x. Just pay attention. Be on high alert for those things. All right, so the crescendo of this part is the simplified polynomial 12x to the third power minus 4 minus 12 minus 8x squared. Negative 4 plus 3x is negative 1x plus 1. So this is the polynomial that results when you're just taking this first block here. All right, so you have to have a lot of endurance with these problems. You have to have a lot of patience. You got to stick to it. All right, this next one, not nearly as bad. You're just doing a one and done multiplication. So you're taking 3x, again, I'll maybe just do the arrows and not necessarily split it apart. I'm taking 3x times 2, which is 6x. 3x times x, which is a positive 3x squared. Negative 1 times 2 is just negative 2. And then a negative 1 times an x is negative 1x. You know what? I'm just going to put it right underneath my 6x because, hey, like terms, maybe it's better if we just put them side by side from the get-go. All right, so the simplified version of this polynomial becomes, I'm going to rewrite it in standard form. 3x squared, 6 minus 1 is plus 5x minus 2. So, this plus, I'm actually, you know what? I'm going to move this over here now. We've got 12x cubed minus 8x squared minus 1x plus 1. There's my first polynomial. I'm adding it to the second polynomial, 3x squared plus 5x minus 2. And I just stacked the like terms. So this is a positive 3x squared, and you get your final answer, 12x cubed. Negative 8 plus 3 is negative 5. X squared. Negative 1x plus 5x is positive 4x. And then plus 1 minus 2 is minus 1. Wow, okay. This really just shows that you know what you're doing. All right? Maybe we skated by a little bit with chapter 2 where it's like, yeah, I kind of know what I'm doing with polynomials, but then I just leave these blank. This is the time where we can really just dig in. If I'm giving you guys 2 days on this, just allow yourself to be taken down the rabbit hole of this might take more time and work than I normally would do with one particular problem. Okay? Last example. It's actually 2 examples that deal with finding expressions that represent area of shaded regions. So we're doing like a throwback to geometry examples here. I'm going to erase all this first, though. I almost slipped on the Chromebook charger. Okay. So it says, write an expression that represents the area of the shaded region below. Then simplify the expression. So the area of the shaded region, well, the shaded region looks kind of like, I don't know, it's like this. It's not really a normal shape that you have like a formula for. Yeah, this thing right here. But here's what basically what it is. It's a rectangle. In fact, it's a square because it's got the same sides here. With a rectangle that's basically been taken out of it. Yeah. So what you can do is you can say, what's the area of the square? Okay. So what's the area of the square? And then from there, we can subtract the area of the inner rectangle. So we figure out what the area of the square is. Okay, so do we remember basic area formulas? Well, any rectangle has an area of length times width. So a square is in the rectangle family. All right, so a square is a rectangle. So you can technically just say area of any rectangle is length times width, L times W. So I can pretty much interchange these two because this is the commutative property works with multiplication, yeah? So it doesn't matter what order I put these in. So the square is going to just be 2x plus 3. We'll just call this length, and then this width is 2x plus 3. Now we know how to multiply that. This is routine at this point. So it's 4x squared plus 2 times 3 is 6x plus 3 times 2 is 6x plus 3 times 3 is 9. All right, so the area of the square is 4x squared plus 12x plus 9. All right, got our first part. Now the area of the inner rectangle. Again, it doesn't matter which one we call the length or the width. I could call this the length. I can put it in parentheses if I want to, but it really isn't required. If it's just one term, that is. And then times 2x minus 1. Well, that's super simple. I just put an x on both of them. This is 2x squared now, and this is minus 1x. So we figured out what the area of the square was. We figured out what the area of the inner rectangle is, but we subtract it because this part of the polynomial is vacant. It's not actually there. It's like this space here, 4x squared plus 12x plus 9, that represents all of this, which would not really represent the area of the shaded region, because this part's not shaded. We got to take it away. So, again, I'll put it over here. 4x squared plus 12x plus 9. Now, I'm subtracting all the parts to this. So when I subtract 2x squared, it's like, okay, I'm taking away 2x squared. That's normal. But when I'm taking away negative 1x, I actually have to distribute a negative through. I got to distribute the negative through to here and to here. That's usually where students make a ticky-tack error, is they forget to distribute that negative on a problem that has shaded region like this. So just remember that that's a minus and negative. It means plus. You're left with 2x squared plus 13x. You still seeing it there? Plus 9. All right, I have an extra example, but this is a 14-minute long video as it is already. I am going to write down the steps for that one, scan it, and then post it on Google Classroom. Because I know everybody's attention span can only hold so much explanation from digital Owsley. All right, so guys, you have 5 problems that they're going to be involved, all right? So you just have to be you have to be patient, and you have to see it to the end. I'm giving you 2 days. Get after it. Good luck.